Okay, so you're back with me? All right, cool. So, listen, let me just show you. Oh, I must get it out, my calculator that you can actually see on this thing out. Um, and we're going to do these calculations when we get to home runs, too. So you might as well get used to seeing them now. All right? So here's what we do. Here's what we do. Is okay, so we said it was 8.5. We kind of did this with the Birdman falling. So we've got this initial velocity going this way, and we've got this initial velocity going this way. We're saying it's 8.5 meters per second that they burst into the air that way at 34 degrees. Okay? All right, well, we know the amount of time. So here's how we would calculate how far they went. Okay? Here's how we'd calculate how far they went. We'd say, okay, well, I've got to find V naught x. Well, V naught x is equal to 8.5 times the cosine of 34. All right? And we could go into the whole SOHCAHTOA thing. I'm just going to keep it. This is the formula you're going to use to find the x component of the velocity. All right? This is what you use. V naught y is equal to 8.5 times the sine of 34. Let's go ahead and plug those in. Here's how this would work on my calculator. It works nicely. I can go 8.5 cosine 34, close the thing, and boom, I get 7 meters per second. And then here I get 8.5 for the y part, 8.5 sine of 34. That's going to be a smaller number. Yeah, it's 4.75 meters per second. That's all there is to it. Now then, I go to this scary equation over here. No big deal. I got to stop putting my big hairy arm in it. I go to this equation here, piece of cake, and I can find the time. Real easy. Watch this. This is so much fun. All right, here we go. So, if I've got look what I said. Just because of symmetry, Mother Nature loves symmetry. What goes up must come down with the same speed, for the most part. For the most part, I know that. Well, they're going to reach it. I know sometimes we worry about people shooting things in the air and them coming down. You know, if they leave the rifle at 350 meters per second, they're going to come down and land at 350 meters per second. No, they're gonna come down and land. They're going to reach a terminal velocity about a third of that. Still, it could kill you. It could really, really hurt, and it could kill you if it hits you in the head when people are just shooting guns in the air. Right? But anyway, so and we're gonna learn about the terminal velocity and stuff like that a little bit later on. All right, in the course. So here we go. So we've got, how could it be much later on? So we've said that V final in the y direction, oh, that'll equal negative 4.75 meters per second. The acceleration that it experiences is negative 9.8 meters per second squared. Very cool. Piece of cake. This is big. So now I just use that equation where I've got V final in the y direction is equal to V initial in the y direction minus GT to find the time. Hey, I know everything. Look, I've got minus 4.75 equals positive 4.75 minus 9.8 times T. I've got a nice little 7th grade algebra problem to solve here. I love it. I freaking love it. So we'll add these two numbers together. So I subtract 4.75 from both sides. Look what I get here. I get T is equal to T is equal to what are negative 9.5 meters per second. Negative 9.5 meters per second is equal to negative 9.8 meters per second squared times the time in seconds. Okay? So that seconds cancels, that one cancels, so I divide negative 9.5 divided by negative 9.8. That's going to give me a positive. The time is always positive, and okay, my calculator looks funny because I have it set on scientific notation. That's about 0.97 seconds. And I'm going to show you what we're going to do with that in the next video real quick, and then we'll move on. All right. This was just an explanation of some stuff that we're going to be doing. All right. File it away. I think the mini lesson actual quiz that you're going to be doing is kind of is a little bit easier,